735 asteroid collision. So given a vector of asteroid, each entry is either positive or negative. A positive value meaning that the asteroid at the position is flying rightward, and negative value indicates that the asteroid is flying leftward. There are three assumptions here. Two asteroids moving in the same direction will never meet. The second one is if two asteroids meet, the smaller one will explode. The third one is if both others are the same size, both will explode. By the three assumptions, the final pattern of asteroid after the collision are the asteroid flying leftward, following by the asteroid flying rightward. And these three special cases are just subcases for the general case here, which is what pattern is not possible is that this asteroid flying rightward is on the left hand side. In this case, these two will collide, so some explosion happen, so this will not be the final state. We use the return type and declare a final state vector. Then we iterate through, starting from the first asteroid, or iterate through each asteroid in the input vector. So for integer I, for the start from 0, I smaller than asteroid size I++. So let's just condition on whether it is flying leftward or rightward. So first, if the asteroid is flying rightward, okay, and of course, on the other hand, it is flying leftward. So if the existing state is a state ends with an asteroid flying leftward, or it can be a state that ends with an asteroid flying rightward. In both these cases, if the newly encountered asteroid is flying rightward, so the first case, the last one is flying leftward, and newly encountered asteroid is flying rightward. They will never meet. The second case, they are both flying rightward. By the assumption 1, they will never meet also. So we can just add this one into the final state. Okay. Let's add this one into the final state. Alright. On the other hand, if the newly encountered asteroid is flying leftward, the first case, it will not collide with anyone. The second case, it will collide with someone in the existing state, right? And it's also a case when there is no one to collide with, so it will not collide with anyone by definition. So for the first and second, we can add the newly encountered asteroid into our state. Okay, so what's the condition? If the existing states are empty. The existing states are empty, alright? Empty. Or the last element is also flying leftward. So the last, which is the back of this vector, which is also flying leftward, then we can add the newly encountered asteroid into our state. Asteroid. On the other hand, this is condition 1 and condition 2, alright? On the other hand, if the last asteroid is flying rightward and the newly encountered asteroid is flying leftward, then we will compare based on assumption 2 and 3 the meeting asteroid they will explored depends one or at least one of the meeting asteroid was explored based on these two assumptions. Alright, so again, if it is plus 10, okay, plus 1, and it is the size of is plus 10 minus 10, flying a mass of 10, asteroid of mass 10 is flying leftward, and the last one is a mass of 10 flying rightward, or 100, exactly the same as smaller. Okay, so for both the first one, the final state will becomes the same, will still remain the same, because the newly encountered asteroid will meet with the last one, but the last one is larger than the newly encountered asteroid, and the newly encountered asteroid, because it has a smaller size than the last asteroid, so it will explode. So the final state remains invariant. The second case, if the last asteroid having the same size with the newly encountered asteroid, then both will explode. So let's go in it. So the state will become x. X is the asteroid one step prior to this one. And the third case is if the last asteroid having a smaller mass, then in this iteration it will explode. Which will explode? The last one will explode, so we will again depend on the second last one to do the iteration again. So the first condition, the second condition, the third condition. Okay, if the last we already know if the last one having a mass that is larger than the newly encountered asteroid mass, then we are not going to push it into our current state, so the state remain invariant. So in this case, we just we just do nothing, right? So what? So just do nothing. So continue. If the mass is equal, then what are we going to do is that we are going to, the two will cancel out, so we need to pop the final asteroid out of the current state. So we pop. Okay. The last condition is that if the newly encountered asteroid have a larger mass than the final asteroid, then what are we going to do is we are also going to pop the last one out, but we are going through the same iteration with the updated state. So we need to deduce our I to go through the same asteroid. Since we add I by 1, in this, if we want to examine the scenario for exactly the same asteroid, then we need to subtract I by 1. And what else? Alright, that's it. Then after the iteration, we should have our final state. Then we can just return it. There's a for loop here. Okay, return. That's rounded. Okay, accept it. Let's submit. Okay, that's it.